Back to more 4.3.1. We're still talking about completing the square. So now for problem number 16, we want to get everything onto the left-hand side first. We're going to subtract x squared from both sides, and we're going to add 11 to both sides. So we have 5x squared minus 5x minus 2 equals 0. Now we're going to divide each term by 2 to get that leading coefficient to be a 1. X squared minus x minus 2/5 equals 0. Isolate, so we're going to add 2/5 to both sides. So our new equation, x squared minus x, leave some space, equals 2/5. Now, what we're going to do is we're going to be adding the middle term, negative 1 over 2 squared, to both sides. So we have x squared minus x plus, and when you square negative 1/2, you get 1 over 4. You square the numerator and the denominator. So that equals 2/5 plus 1/4. Now we factor the left-hand side, and it's actually easier to factor than you think. It's x, and right there, the negative 1 over 2, since we can't do anything else with it, it's just going to be minus 1 over 2 squared. There's the left-hand side factored, equals. Now we have to add the 2/5 and 1/4. I'm going to do that over here. 2/5 plus 1/4. The common denominator is 20. So we're going to multiply the first fraction by 4 over 4. So we get 8 over 20. And you multiply the 1/4 by 5 over 5. That gives us plus 5 over 20. So that's going to be 13 over 20. So x minus 1/2 squared equals 13 over 20. Take the square root of both sides. So we get x minus 1/2 equals plus or minus. Now, the square root of 13 over 20. Taking the square root of a fraction, you take the square root of the numerator, the square root of 13, square root of the denominator, the square root of 20. Now, the square root of 20, we have the square root of 13, and the square root of 20, sorry, I'm doing a lot of work off to the side here, is the square root of 4 times the square root of 5, so it's 2 square root of 5. We can't leave the radical in the denominator, so we're going to multiply by the square root of 5 over the square root of 5. So we get the square root of, you can put them back together, 13 times 5 under the square root over 2 times the square root of 5 times the square root of 5, which is 5. So it's the square root of 65 over 10. And then to finish up, we just add 1/2 to both sides. So x equals 1/2 plus or minus the square root of 65 over 10. And there is our answer by completing the square. Now you can see completing the square can get kind of messy, especially when we're dealing with the fractions like we had here. Now, this is not in your notes. You don't have to write anything down, but I want to show you what happens if we solve a quadratic in that general form. So I'm going to solve ax squared plus bx plus c equals 0. Don't write this down. I just want you to see what happens. We're going to divide everything by a to get that leading coefficient of 1. So it's x squared plus b over a times x plus c over a equals 0. So I'm going to subtract c over a from both sides. X squared plus b over a, leave some space, equals negative c over a. Now in that space, I'm going to be adding b over a divided by 2 squared. Now, I'm going to clean that up a little bit. It's pretty messy. B over a divided by 2. Now, b over a divided by 2, that's b over a times the reciprocal, 1/2. So that's going to be b over 2a, and we're squaring that. So it's x squared plus b over a times x plus And when we square b over 2a, we get b squared over 2 squared, which is 4a squared. So we're going to get plus b squared over 4a squared equals negative c over a plus b squared over 4a squared. So when we factor this, x squared, and now that middle term is that b over 2a. So it's x, excuse me, it's going to be x plus b over 2a squared equals, and I'm going to rewrite this so that it's, actually we'll leave it there. So to add those fractions, I need to multiply by 4a over 4a to get my common denominator. So it's going to be negative 4ac over 4a squared plus b squared over 4a squared. So on the left-hand side, we get x plus b over 2a squared still equals, and when I rewrite this, it's b squared minus 4ac over 4a squared. We just combined those two fractions. We added them up. Take the square root of both sides. X plus b over 2a equals plus or minus. Now, when we take the square root of b squared minus 4ac over 4a squared, we take the square root of the numerator, b squared minus 4ac. I can't really do anything with that. Now the square root of 4a squared. So it's the square root of b squared minus 4ac over, and when we take the square root of 4a squared, we take the square root of 4 and the square root of a squared, that gives us 2a. So now I subtract b over 2a from both sides. And what I get is x equals negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. And since these both have the same denominator of 2a, x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. There is what we get when we solve by completing the square. We get the quadratic formula. And there it is. When you solve a basic quadratic by completing the square, you end up with the quadratic formula. So completing the square isn't always the best method to solving a quadratic. Sometimes when the numbers get too messy with a lot of fractions, you want to use the quadratic formula. It just works out better that way. All right, now we're going to talk about rewriting by completing the square to get into how to get it into vertex form, that graphing form. So we leave the y as is. So we're going to get a leading coefficient of 1, which we have. So I subtract 95 from both sides. Y minus 95, leave some space, equals x squared plus 18x. And now what we're going to do is we're going to be adding the middle term, adding the 18 divided by 2 squared to both sides, just like we did before. So you get y minus 95. 18 divided by 2 is 9. Squared is going to be plus 81 equals x squared plus 18x plus 81. So you get y minus 14 equals, and when you factor, you get x, and then 18 divided by 2 is a positive 9 squared. And then we just isolate the y by adding 14 to both sides. So you get y equals x plus 9 squared plus 14. Now what we have is our quadratic out of standard form and into that vertex form, that graphing form. And our vertex is located at negative 9, 14. We're not fully solving, we're just rewriting. So for number 18, leading coefficient is 1, we subtract 22 from both sides. Y minus 22, leave some space, equals x squared minus 10x. And we're going to be adding the middle term, negative 10 divided by 2 squared to both sides. Y minus 22 plus negative 10 divided by 2 is negative 5. Squared is a positive 25. So that equals x squared minus 10x plus 25. So we get y plus 3 equals x minus 5 squared. Remember that negative 5 comes right from there, the negative 10 divided by 2. Now we just isolate the y by subtracting 3 from both sides. Y equals the quantity of x minus 5 squared minus 3. There's our rewritten quadratic, and the vertex is at 5, negative 3. For number 19, same thing, subtract 50 from both sides. Our leading coefficients are already 1. Y minus 50, leave some space, equals x squared minus 20x. Now we're going to be adding the negative 20 divided by 2 squared. Y minus 50. Negative 20 divided by 2 is negative 10. Squared is going to be plus 100. X squared minus 20x plus 100. So we get y plus 50 equals, and when we factor, we get x minus 10 squared. Subtract 50 from both sides. Y equals x minus 10 squared minus 50. And there is our rewritten quadratic. And our vertex is located at 10, negative 50. And then finally, leading coefficients 1, we subtract 29 from both sides. Y minus 29, leave some space, equals x squared plus 12x. So we're going to be adding 12 divided by 2 squared to both sides. So you get y minus 29. 12 divided by 2 is 6. Squared is plus 36. And that equals x squared plus 12x plus 36. So y plus 13 equals, and then you get x, and then remember from 12 divided by 2, that's 6, so it's positive 6 squared. And then we subtract 13. So y equals the quantity of x plus 6 squared minus 13. So the vertex is at negative 6, negative 13. Okay, and that was some more completing the square, showing you how completing the square and quadratic formula are connected, and also how to rewrite from standard form into vertex form using that completing the square as well. Thank you, and I will see you in the next video.